Okay, so we're going to look at dilations. If everybody could take your AirPods out, put them up, and lean into this lesson. This is very short, straight, simple, no tricks. And yet some people struggle with it, and I think it's because they don't give me their full attention. They think they just take in part of it. Once I show you one of them, you're probably going to be able to take off with the rest of them, okay? This little flip book on the front of the flip book is giving you an example of each of the two types of dilations. There's only two scenarios. Scenario one is called everybody read it out loud, reduction. Scenario two is called a enlargement. When you hear the word dilation, a lot of people think it means like your pupils get small or big, right? I guess you could go either way. If you have dilated pupils, then you could think of someone like in a dark room and their pupils are really big because their eyes are having to take in more light because it's dark. If you step outside, yesterday, solar eclipse, and your eyes, the sun's shining, your eyes get dilated as well, but this time the pupil gets really small because if it lets in too much light, it hurts your eyes, right? She's on the way. So dilation, I need you to know that dilation means either direction, okay? It doesn't mean always big or always small. It means either direction. How do you know if it's a reduction or an enlargement? By the number you're dilating by. So you did the mini golf thing, right? You were dilating by a certain number, which means you had to take the segment, resize it so that when you dilated it, it would land in the hole, right? If you look at this front of your notes, we've got reduction or enlargement, and then to the right of it, you see the letter K. You know how the letter M stands for slope? Everybody with me? Slope, M. K, dilation. All right? Don't ask me why. I don't know. But it means it stands for dilation. If you want to highlight this, you can. I'm just doing it to make it stand out because it kind of all blends in. If the number you're dilating by is smaller than 1, then it's a reduction. If the number you're dilating by is bigger than 1, it's an what? Enlargement. This is good news because this means that the number I'm dilating by is literally going to tell me exactly what's happening. Either it's getting bigger or it's getting smaller. Okay? Now, how do you actually dilate? It's a matter of reading the coordinate points and then multiplying by the dilating factor. So, notice we're getting back to those words pre-image and image. Pre-image means before you do anything. Image is when you've done something to it. Let's get the coordinate points for A, B, and C. I need you to read the coordinate points for A, B, and C. Read the coordinate points for A, B, and C. Remember, right or left first, then up or down. So did you get -3, 3, -3, -3, and 3, -3? Okay. We're going to dilate this pre-image by a factor of 1/3. Okay, I need everybody to think to yourself, if I'm dilating by a factor of 1/3, is that less than 1 or greater than 1? It's less than 1. So my shape should be getting what? Good. Smaller. So when you go to draw the new shape, if you've drawn it bigger, you know something's wrong, right? How do we actually get it? You're going to, so let me make a note over here. You can write this if you want. It depends on, you can put it on your notebook paper. So to dilate, multiply x and y by k. All right? Which means, I'm going to draw an arrow to say, like, that means you're going to have k times x and k times y. Now, what is k here? K is 1/3. So we're going to multiply 1/3 with every single one of these numbers to get our a prime, b prime, c prime. Now, you could do this in your head because these numbers are nice and convenient, but let's pretend like one, it's been a while, you've not done math in over a week, and you're just running on empty right now. Or let's pretend like it's numbers that you're not used to working with. Let me show you how to do it in the calculator. Alright, I can only show point A in that calculator is too big. Okay, so I'm going to multiply each number by 1/3. I really only have to do this, if you think about it, one time, because what are all the numbers in this pre-image? It's 3. It's either positive 3 or negative 3, which is just a difference in sign. Alright, so I'm going to multiply that, negative 3, by k. K is 1/3. There's two ways to type 1/3. I personally like the math print feature, which is alpha y equals, y'all remember that, 1/3, y'all sit up, please, 1/3, and we get -1. And now, do I need to type it again with the positive 3? You shook your head no. Why not? What's it going to be? Yeah, it's just a sign change. So if you like the math print mode, it was alpha y equals. If you don't like the math print mode, call me over and I will show you another way to type the fraction. But I like the math print because I can actually see the fraction there. You know what I mean? All right, so this a prime is going to be -1. And then now, take your non-writing finger, index finger, and make sure you're keeping track of what you're multiplying. Now multiplying 3 by 1/3. What should it be? 1. All right, b prime. Houston, what did you get for b prime? Yep, very good. Will, what'd you get for c prime? Yep. And then now let's graph it. Go ahead and graph it right there. Now, in the Desmos activity, what were we dilating? Was it a triangle? What would you say it was? Do what? A line segment. So we played mini golf this morning. Love it. I would love to show you actually, because you successfully dilated this triangle by a factor of 1/3, and it reduced, it shrunk in size. What do you think is going to happen when I dilate by a factor of 3? Use a word to describe. Blanket size. Yes. Give me a number. Triple. 3 times. 3 works. I was looking for triple.
You were there.
You were there.
It counts.
It counted.
So,
Just like in that putt-putt.
yeah,
That
it
one
counts.
counted. All right, please dilate that one right there. You're dilating by a factor of 3. No, I'm not worried about it. If she was to say something, I'd let her know that you're not actually in
I think I'm supposed to.
your COA.
I'm supposed to be in the library, but that's not gonna happen.
So you're dilating by a factor of 3. Get the coordinate points for A prime, B prime, C prime, or A, B, C, sorry. Then get A prime, B prime, C prime. Yes, all the coordinate, X and Y. Yes. Oh, I said A, B, C. Now this one you probably didn't need your calculator too much because you're multiplying by 3. What is the coordinate points for D prime? Carol. Very good. Coordinate points for E prime, Leah. Yep. Coordinate points for F prime, Hannah. Yep. And then we're going to graph it. So these 2 pictures, one's an enlargement, one's a reduction. You'll notice that it was the exact same triangle that you found in the last one. These are the only 2 scenarios for dilations. The only thing that gets ugly is if you're dilating by a factor of 2/3. But in that case, you know how to type it in the calculator. Alpha y equals 2/3. Let's open up the book and let's do the 4 practice problems. You have 4 of them here. You will notice across the top you're dilating by fractions less than 1, and across the bottom you're dilating by numbers bigger than 1. The first thing you need to do is to find the coordinate points. And this might be something you want to do just for all of them to start with, systematically. So this is A, B, C. This one's D, E, F, G. This one's H, I, J. Then we got K, L, M, N. Then we'll do the primes of those. now you're going to type these in the calculator to get the answers. I would like everyone to start with this one. Start with this one because you are going to get a decimal. You're going to get a decimal on the new image, and I want you to feel comfortable graphing decimals. They are pretty decimals. It's 0.5. So everyone try that one first. This is -3.4. Check my numbers. Was right? Is that what you got? All right. So we're going to multiply by 1/2. Let's think creatively here. If I want to multiply by 1/2, what would be a convenient decimal I could type in that would be easier than typing the fraction 1/2? What? 0.5. So that's a problem-solving skill. Look for opportunities to take a fraction and write it as a decimal because it'll be faster. 0.5. So I'm going to multiply -3 times 0.5. If you'll type it in as a decimal, it's going to give it to you as a decimal. If you type -3 times alpha y equals, and then type 1/2, it's going to give it to you as a fraction. But, two things. One, you could say to yourself, well, if I had $3, always relate to money, it's easier. If I had $3 and I need to split it between 2 people, that's how much each? It's $1.50, right? Money's easier to work with because everybody knows money. Or there's this button, math. The number 2 option, DEC, means go to decimal. So you can say, hey, I need you to send that to me as a decimal. So if the fraction can be written as a decimal, go ahead and use that because then it's going to produce the decimal. Decimals are easier to graph. If you forget and you have a fraction here, just hit math decimal. It'll give it to you as a decimal. So this is -1.5. And then 4, if I cut 4 in half, that would be 2. B prime would be -1.5, -1.5. C prime, if I cut 2 in half, I get 1, and then I got -1.5. All right, now we have to graph this. Don't let the decimal make you forget where -1.5 falls between. Think of a number line, right? And you are in the negatives, so pay attention. -1.5 is between what 2 numbers? 1 and 2. -1, -2. So we're going to go left 1, and then this is 1. This would be -2. So I'm just going to go halfway in between them, right? So -1.5 would be about right there. And then I'm going to go up 2. So up 2, so it's going to land there. You see that? Now I'm going to go left -1.5 and then down -1.5. So left 1.5. Down 1, and then halfway is going to put me right in the middle of that box. Then right 1, down 1.5. Don't let the decimals make you feel like you don't know how to dilate. We already did 2 dilations on the front. You're just multiplying the numbers by the scale factor, okay? The scale factor is what's telling you how much you're changing the size of the image. All right, let's do one to boost our confidence. Everybody come to this one. You're dilating by 2.5, so you're just going to type that in the calculator. Multiply the numbers by 2.5. Then you're going to graph it. So we're multiplying HIJ by 2.5. I think you typed it in as 2/5. Make sure you're typing, so this is your scale factor right here. We're typing times 2.5 to the X's and the Y's. And you should get nice numbers. So now it's pulling up your previous answer. You just gotta get out of it. And now you should be, oh, no. It's because you're hitting, you're hitting subtract instead of negative. That's the difference. So when you multiply these, did you get these nice numbers? These are not nice. Well, they're not hideous, but they're not, I thought they were whole numbers. I was looking for the wrong problem. -2.5, -2.5. Did you get that there? And then 5, -2.5. 5, +2.5. Yes? So we're going to graph it. So we're going to go left 2 and then just halfway to the 3. So left 2, halfway. Then go down 2, halfway. So we're hovering in that box. Now we're going to go right 5, down 2.5. we're gonna go right 5 up 2.5. All right, 2 more. Let's do this one right here. What is a way to write 3/4 in decimal form? Think money. Think quarters. 0.75 is the decimal form of 3/4. So instead of multiplying by 3/4, I could multiply by 0.75. And that would give me the decimals that I need. Okay? Let's get the coordinates for D, E, F, and G. Then go through and multiply by 0.75. You are going to get a new decimal, 0.25. No, 0.2. Yeah, 0.25. That's a quarter, right? Decimals that end in 0.25, 0.5, 0.75, and technically 0. If you think of quarters, it makes it easier. So here we get negative 2.253. Did you get that? Make sure you're multiplying this in your calculator. Now you might be thinking, how am I going to graph this? You're going to go to 2 or negative 2, and then you're just going to go a little past it. 0.25 just means a little past it, okay? Don't get caught up on the technicality of 0.25. So we're going to go left 2 and a little past, and then up 3. Left 2, little past, up 1, 2, 3. We're going to go right 2, a little past, up 3. Let's see how this is forming. We're going to go right 2, a little past, down 3. Left 2, a little past, down 3. All right, we have one left, and when you're trying to read the pre-image, you may be struggling to figure out the coordinates of M and N. It looks like if it were me, I would say it's halfway. So I'd go with 0.5. M looks like it went right 1 and then down half. N looks like it went left 1 and then down half. This one, your scale factor is 2, which means we're doubling it, right? So this one you may not even need your calculator because you're just doubling these numbers. Watch your signs. If you're doubling -1, then it's going to be -2, right? So I double -1, 2, and I would get -2, 4. I would double 1, 2, and I would get 2, 4. If I double half, then I get 1. Oh, no, it's negative, so it'd be -1. And you should be able to graph that.